Hey everybody, my name is Milecia McGregor and I'm a developer advocate at Conducto, and we make our own CI/CD tool that will eventually change the game for all of that. So ours is different because we use Python instead of YAML, which is actually really cool. But I digress. Today we're going to talk about making your React apps more performant at scale. So this is something that I've talked about before and I do a lot for work and for fun because I'm that kind of person. But hopefully this talk will give you some tools and some ideas about what you can do to make your app run faster, how you can figure out where you need to improve things, and just some good refactoring things that if you haven't done them to your React app yet, it might be a good idea to consider it. So before I start any talk, I always like to give a quick overview because especially with all of the virtual stuff, I know how it is. We fade in and out, and I want to make sure that you at least catch the parts you're the most interested in. So first we'll talk about what your initial React app is like and how it gets set up. Then we'll talk about what happens over time as we go through the software development lifecycle. And then we'll finally get into one of the fun parts. So we'll talk about testing your React app for improvements that can be made. We'll get into how to keep your app performant over time. And we'll talk about some things you can do to clean up existing apps to make them more performant and just better to work with. And lastly, we'll wrap up with just a few key takeaways and some things that I really hope you can take back to work with you or wherever you're going. So, to get started, let's talk about our initial React apps. We usually start with, a nice CRA. So we have a nice shiny new repo that looks something like this. There's not a lot going on in here yet. We have the source folder. It doesn't have any subdirectories. And if you take a look at the component we have, it would be a stretch to say we could make this more performant. But this is how our app usually starts. There's not much going on here. Everything is really clean. It's open, and we just use this to, get the framework stuff out the way easier. But what happens over time is that we start developing these apps. We add components. We make helper functions. We call APIs. We do so many different things. So over time, that nice, shiny new Create React app that we began with, it just becomes so much more. So I have a little demo app that I made for this talk. And as you can see, this is the part that is the Create React app. So we've added a new components folder. There's some helpers that are going to get added. And in the components, you see we have a subfolder. We have more components than we definitely did with that initial Create React app. And there are just a lot of things going on. So we have modals that rely on different functions. We have data that needs to be queried and processed. We have just different components, like for stylistic reasons or whatever reasons. We have all of these new components. They're being used in a lot of different places. We're making calls to some API to get the data, and we have to make sure that as we add more layers like this onto our app, that it's not slowing down for users, at least not substantially. I mean, there are some things that, I'm sorry, it's just going to take that extra 200 milliseconds. It just is. But we don't want those to keep adding up until we're at, oh my gosh, this page is taking 30 seconds to render for the first time. That is what we're trying to avoid. So I wanted to show you what the app looks like. So this is the app. It's a little budget tracker. I didn't connect it to my local database because I don't want you to see my spending habits right now. There has been way too much food that I bought this month. So we're just gonna pretend that there's data here, and we know we could add an item with this form, so that's automatically one API call. And normally this does load in data the first time it's rendered, so that's another API call. Then we want to sort by week or by type. That is another API call. So this, well, maybe that one's not, but it's another thing that the browser has to handle. And this is where all of those complexities come in. This is how your app gets bogged down over time. And this is just a very bare bones demo of how an app would come together. So again, this is one of those, I didn't really want you to see what my goals were because I did not meet them at all this month. But it's just another view for you to see, hey, it's a React app. It has all of the parts that my React app has. So there should be some little commonalities that you see. But anyways, back in here, we know what the app looks like. We know what happens to it over time. So let's talk about how we can figure out where to start looking for these performance improvements. So one of the things that we can do is like a performance audit on our app. And that just means we take advantage of some of the tools we have available to us to just figure out what's running slow, maybe where some silent errors are happening that we can fix, and things like that. So the first thing you want to do, usually we're doing our performance checks on a local build. So if you're not testing in prod, which for something like this wouldn't be a terrible idea, there's nothing destructive happening here, but just in case you want to start making those performance improvements, you'll want to make a production build on your local machine because it has all of the bundling done, it has all of the assets loaded to wherever they need to be loaded, and it has the configuration for whatever your prod app should be like. That's what you need to know what your performance is. Like, that's where you need to know where your performance is. So use a production build when you're running this audit locally. And then one of the first tools we'll look at is Lighthouse. So back over here, I'll just move this out to a separate window so I can leave my presentation big. Let me get that back up real quick. Okay, so we're on Lighthouse, and that's part of the reason why I made this little demo app. But what we're gonna do is open the browser tools. So I'm using Chrome, and if I recall right, I'm not sure if any of the other browsers actually have these tools. So if you're using Firefox or Brave or something like that, just be aware you might not see these same tools. But if you're using Chrome, which I highly suggest, you can just go up here to this Lighthouse tab and you can see the categories that it's going to test your app for. So we definitely want to know about, well, all of these. So we'll go ahead and just click Generate Report. And it's going to go through the app and look at a lot of different things. So it takes it offline to see how it responds. Then it resizes things, it clicks things and checks text, all that good stuff. So sometimes if you have a large app, it might take Lighthouse a little while to finish its audit, do its testing. But it looks like we're almost done. Okay. So, as you can see, this app definitely needs some help with performance, which isn't a surprise because that's why I made it, so you can see that. But really what happens is down here, you can see a breakdown of what your I guess, negative things were, what really needs to be improved. And they also give you these really, really nice, like, tips. So they tell you some of the things that you can do to make your app more performant, like getting rid of like legacy JavaScript or making sure that you're caching things correctly. So it just tells you a good breakdown of what you can do to make it better, and it gives you some specifics based on the metrics that it checks for. So Lighthouse is a really good tool just to get started with and see where you can at least begin to make improvements. So the next tool we'll look at is the Profiler tool. So the Profiler tool is also a part of the Chrome Dev Tools, but it is pretty cool. If I can get my tabs to switch right. So you'll see over here is the Profiler tool. So we'll click on that. And one thing I'll do, I always mess this up. So I'm gonna click Start, and then I'm gonna refresh the page. And then I'll reload. Oh, there we go. I always do that weird, but basically you start profiling, then you stop, and then it shows you how long components took to load. So that's the beauty of the Profiler tool. This gives you a breakdown to the milliseconds of how long each component took to render on the screen. So that's a really great way to see where you can really focus on. As you can see, the app didn't take that long, header didn't take that long, we got some styled components, all that good stuff. But this chart took the biggest chunk of time out of everything. So that means we'll probably want to start looking for improvements with this victory chart component. And it's a third-party component, so maybe something you would consider is looking at a different third-party library, or maybe if you were going to use it enough, you could make your own like house chart library. But that is basically what the Profiler does. I usually like to use this ranked view because you don't have to look that hard. It shows you what's wrong really fast. And then the interactions tab, I haven't had much of a chance to use that, but typically the ranked and the flame graph will show you, like, this shows you the order of things happening, and ranked just shows you what takes the longest time. All right, so on to the next. The network tab. I'm pretty sure that y'all have used this network tab before when you're trying to work with the backend team and you're not getting data. They say they're sending data. You think that your request is right, they think you're sending the wrong params, or maybe you just run into some weird thing where the API call just isn't working. Usually you can track those kind of things down in the network tab. So in our case, we'll come back over here to the Dev Tools, go to Network, and boom, you can already see an error. So the reason that this error happened is, well, I don't have the server running. That would cause some problems. But the point of that is just to show you, hey, if you think you're having a data problem or you want to find out how your data is really structured so that you can change how you're filtering it or sorting it on the front end if you have to do that, this is a really good place to look. So now we're going to talk about some of the other Chrome Dev tools. And really the only one that I have to jump into pretty decently would be this Components tab. And this just shows you all of your React components. So fun fact, just want to throw this out here real quick. If you give your functional components, like if you don't make them anonymous, if you use the keyword functions and you describe it like that and all that good stuff, you'll actually be able to see the name of this component in your DevTools. So I don't know if, oh yeah, I'm not on the items page, but let's go to items really quick, just to show you. But yeah, so basically with that components tool, when you go to a page, I guess I don't have any items, so maybe not the best example. It's fine. We'll just move on like I did that right. But maybe the goals, maybe I did do that one the correct way. Nope, I didn't. Whatever. Usually you have to have that named as a function for it to show up in there, but neither here nor there. Maybe that's just for styled components, I forget. But whatever it is, you can see your props, you can look at your current states, you can see the render tree. So looking through this components tab will really help you when you find a component that might be having some issues. It'll help you drill into the root of it, if with nothing else by showing you the render path. So now that we've gotten through all of the testing things, let's talk about keeping your app performant. So one of the first things you might consider is virtualizing long lists. And that basically means that you only load in the list data when you need it. So React docs, somewhere in the React docs, there's a nice little blurb on virtualizing lists. And then lazy loading. So this one is almost legendary. Not only does it help with performance, it actually helps improve user experience too. So if I come over here back into the example code, I'm going to show you where I lazily load in the goals component. So in the home, I just use react.lazy to do my import. And this means we only import this component when we need it. So we only import the goals component when we're going to the goals route. And what that does, it saves us all of that upfront loading time where usually we load in all of the components we need up front. You don't really have to do that because you're probably not going to be on the same route twice, if that makes sense. You're only going to be on one route at a time. The page is only going to change when that route changes. So you don't need these components just hanging out there, taking up time and space. That's why we use React Lazy for dynamically importing our components. And then down here, this is the part that makes it a tiny bit more user-friendly. So you know how when you're going to a page that has a lot of data on it, it might just not do anything for a while. Like it doesn't tell you something's wrong. It doesn't tell you it's doing anything. And then all of a sudden the page just flickers and it's there. The suspense component is a part of the whole lazy loading thing because it is lazily loaded. You need to have some kind of message or icon or other component that shows the user, hey, this page is loading, just give it maybe a couple of seconds, a microsecond, something like that. It just saves that awkward skip from a component being loaded to a user. But you can lazy load all of your components, especially at that root level. So usually components go in a routes file or something like that. If you lazily loaded in all of the components for your entire app, that would save you so much on your performance time. And then one more thing we're going to talk about a little bit later. So you've got your lazy loading. Now you need to make sure you're caching data. Caching honestly can be a little bit of work, but if you take a look at Google Workbox, they've done a lot to make it easier. I say that with a grain of salt because service workers they're just a little hard, but once you get yours working, the cache the cache that you'll create is worth all of that extra work, because it will save you so much time on re-downloading assets or re-querying an API when a page hasn't changed, or when a user goes offline, it'll still show the app most of the way, if not the whole way. So take the time to work on setting up your service workers and cache that data. And minimize everything. This is probably something that's happening in your Webpack config somewhere, but just make sure all of your JavaScript is minimized. Any external HTML or CSS you have is minimized, but make sure you have minimized everything that you possibly can. And then something else that surprises us sometimes is how much error handling helps with performance. So when an error goes unhandled, a lot of times that will hang up an entire application, or it'll make it so you can't work on a certain page, or you have to keep refreshing things. And it just causes a lot of headache. It causes a lot of issues for your users, and that's the last thing we want to do, is cause issues for our users. So take the time and handle your errors. If there's anywhere that a null or undefined value can sneak through, make sure that you are handling that. I know TypeScript is kind of like the standard, maybe it's the standard now, but if you're not using TypeScript, you should strongly consider it, because having those types really helps you make sure that your app is, well, less error prone. So make sure you're handling errors is all I'm trying to say. And then to kind of tie a couple of things together, we want to make sure that our bundles are chunked. You really don't need to serve up a 24 megabyte page. Like, you don't need to serve up your entire website in one file. And something that helps with chunking your bundles is lazy loading and minimizing everything. So when you have everything minimized and you're lazily loading in components, that means your bundles get split up just a tiny bit more. So instead of one super large chunk, you'll have multiple tiny chunks that only get used when they need to be used. There's not as much waste, if that makes sense. So now you know about keeping an app performant. How you clean one up. A lot of times we all walk into these existing projects and there is no way we can start at greenfield and get up to speed fast enough. So we need to do some good old refactoring. The first thing that you should consider is code splitting. So code splitting is basically like making sure that your bundles are actually small. So that's just gonna be handled with things like our lazy loading. So lazy loading chunks up things a little bit more, and Webpack does some fancy magic stuff to take those lazily loaded components and chunk them individually. And that just it decreases your bundle sizes, which means that the page can load faster on any network a user might be using, and they can just get all of that benefit from an existing app. Then there's tree shaking. And tree shaking is actually a lot of fun because you just get to go through and delete stuff. You're getting rid of code that isn't being used anywhere. You're getting rid of those variables that got forgotten before a developer pushed up changes. You're just going through and really cleaning things up with a fine-tooth comb. So there won't be any of those unused comments. There won't be any unnecessary functions there. So if you can refactor a function or functions, then this is where and why you would do it. You're trying to get rid of code that's not being used and improve any code that's already there. This one is a really, really big one. So make sure that you check for any unused packages. Those npm packages can be enormous, and when you have to include them in a project that's getting rendered in the browser, you don't want an enormous npm library. So make sure everything you have imported in your project, everything that's defined in that package.json, make sure it's being used. If it's not, get rid of it. And if you do have the option of just choosing specific parts of a package, like, for instance, you might not use the entire Lodash library, so maybe you can get by just including the bits and pieces of that library you need. Something else that helps a lot is maybe not anytime, but most cases, if you get the chance to use the use context hook, that'll also save you some performance time. Because basically, the use context hook keeps you from prop drilling. So that means you won't have to pass variables 3 or 5 components deep, and it's only being used in the parent component and that 5th child component. With the use context hook, you can just get the data you need in the places that you want. So if you have let's say we have that goals modal or the items modal or any modal that's up with a form in it, and you want to save that data from the modal form to some endpoint that is only called on the page you open the modal from. This is a case that maybe use context would help. You can pass the params back and forth between components without having to touch anything in the middle. And then the use memo hook is incredible. This one checks to make sure that there aren't any changes to your data before it goes ahead and tries to re-render with new data. And then, of course, just refactor. Some good old cleaning up things, maybe simplify some array methods and filtering, or maybe you can, do a number of things. Maybe you can use some use effect hooks or change a state or combine some functions, make a new helper function, whatever it is. As you go through an existing app, you'll start to see a lot of those places where you can improve the code itself. So with that being said, we have made it to the end. Congratulations. So a few things that I want you to take away from today would be performance issues just happen over time. It's a part of the software development lifecycle, and it's just something that we can't avoid. We add more components, we add more backend requests, so performance just slows down over time. But there are plenty of free tools to use to make sure that you're keeping an eye on your performance at least. At least you'll know when things start to diverge, and you can kind of make a plan for how to handle that. And then something that I really like to drive home is, in general, most coding things, I always hate when people feel like it's too hard. It's not too hard, it just takes time. So most of these performance issues you run into, they aren't necessarily hard to solve, they just will take time to figure out the best approach to solve them. And then make sure that your resources scale. There are some times where you just need more server resources. Maybe you need to increase the amount of memory you have on the server, or maybe you need more CPU, something like that. Just make sure that your actual server resources are not the blame for the performance issues. And then again, keep an eye out for those unnecessary packages. Those will add so much so much to your project that you really don't need in there. So make sure you keep an eye on that. And then always document why you're writing code a specific way. It's not a performance thing, but sometimes it helps when you go back months later and look at code and you're wondering, well, why would I have made this so complicated? Just leave a quick little comment in there for yourself and you will be able to figure it out a lot faster than if that comment wasn't there. So thanks for listening. I hope that this was a good talk and you were able to learn something. And I'll be around for the Q&A, but if you have questions, you can also hit me up on Twitter at FlippedCoding. Thanks again.
Okay, so thanks for the talk, Milecia. I think it was a great overview of what you can do with your app. And first, we can check out the results of the poll. So based on what I see here, most people, they work with code bases that are between 10 to 100 lines, and then there are bigger ones, of course. So this like 100 to 1,000 and even more than 1,000. And that, for me, that's a really big app. So what do you think of the results, Milecia? Is this something you would agree with, that most apps are quite small, but then you have the huge React apps as well?
I think that most of the React apps are pretty small. Like, I don't know. Once you get past 100 files, that's a lot of different components and things going on. So it might be time to split some stuff out into other services or something else.
Yeah, it's like a lot of views, and I imagine it must be really, really hard to optimize something that's a big app.
Mm-hmm.
Yeah. So let's check out the Q&A. So we have got quite a few questions. I guess the first one that's good to ask is, what are some ways to handle state effectively? What ways do you prefer for state management?
So I think that the hooks that are built into React are good enough to handle any state thing. So no more Redux or MobX or any of the other state management libraries, unless you're doing something super complex. But personally, I think use state is enough. You can add in some third-party libraries for like form state management in particular or things like that.
Yeah, it's interesting because we have moved to in step by step with React and from one solution to another, and now we have recoil and whatever. So it's like it's never ending, but it's true that what we get out of the box with React it's quite a lot. Do you know any workshops? This from Cynthia. Do you know any workshops on this topic that you can recommend for people that want to learn more?
Actually, I don't know any workshops on like React performance in particular.
So how did you learn about these performance optimizations, or how did you pick up your knowledge?
Honestly, just a lot of different projects. There would be times we run into some really, really weird performance issues when we changed APIs or added new components or something else, and it turned into me having to learn about all of these tools to figure out the best way to approach our cleanup, or how to figure out maybe if we should change the architecture of things around to not render as many components on a screen or something like that. So it just came from a lot of trial and error.
Yeah, I understand. I mean, that's pretty much how I learn as well. It's just you have to learn it in practice in part, but that's why we have this session, so people don't have to do the same. And then this third question is, do you think that use context is better than Redux?
Personally, yes. I think it is better than Redux, just because I feel like it gives you more control. So instead of having that giant global store, you have these individual things that you can manage and add and take out and move around however you want. And it's already built into React, so you don't have to add another dependency.
Yeah, that's true. I mean, my understanding based on recent experience is that the context at the moment, it has some limitations. So what you're gonna end up is that if you have too many things at the context, then it can be sort of heavy render-wise. So there's some like I think for a lot of use cases it's fine, but at the same time there's a reason why we have new solutions like Recoil on the market. So next one from Marcus. What is the shortest way to boost up the performance of a React app from your experience? Like, what's the first thing you would do on a React app that has some performance issue?
The first thing I would do is probably run a Lighthouse audit, and then I would probably run the profiler tool just to get an idea where some of the problem areas are. But once I figured out where those problem areas were, I would jump into that particular component and see if maybe there's some backend calls that can be simplified, or maybe we can refactor some code and get rid of a dependency, or maybe there's a different way we can handle images loading, or just things like that. But I usually start with a quick Lighthouse check and a quick profiler run.
Yeah, I think it makes sense, because if you don't know what to optimize, then how do you optimize? So it's important to have some kind of view on what to do. And then there's a question about these tools included in Chrome. The person asking the question doesn't find the profiler tool or the components tab. So is he missing something? I know the answer, but
I think there's an extension I have installed.
Yeah, I think so too. I think the point is that you need this React extension for Chrome. It doesn't have
the React developer tools.
Exactly, yeah. So for you to see these extra tabs, you need to install the React extension. And there's a good question about this from Ante about performance checklists. So do you know any particular checklists or materials where to read more? Because it sort of makes sense that you will have a list and you will go through the list against your app to figure out what's up. So are you aware of these kind of resources?
I actually don't have any, but now I think I'll write one of those just to post it up.
Yeah, I think that makes sense, because it will be highly useful, because then what you will do, you will profile your app and then go through the things one by one.
Yeah, I'll write an article about that.
Yeah, cool. We can share it later with the audience. I think it's a good idea. Okay, and then there is one more about there's recommended ESLint rule for exhaustive depths in use effect that complain about empty array. So are you familiar with this rule, or do you know why it's recommended? I mean, maybe it's too specific. We can discuss this later as well, but it's
yeah. So usually you'll want the empty array at the end of a use effect statement, because if you don't, it will just run that use effect callback forever. So if you don't want that to continuously run on the page, and you only want whatever's in the use effect to run when the page is loaded, then you really need those square brackets. You really need square brackets anyways, or else you just get stuck in that infinite loop.
Yeah, I think that makes sense, because if you don't have that, then it's we have this trigger issue. Yeah. So I think that was that was it. I think, and I think we can start moving to the next talk by Nick. So thanks a lot for the great presentation, and I think we learned a lot.
Yeah, thank you.